Okay, let's get into our next concept, which is actually pretty simple. It's daunting at first, but it's a really simple idea. There's two we're going to talk about, which is arc length and areas of sectors. I'm going to start with the area of sectors because it's the easier one, and I think it's totally doable. Let's say you had a pizza, and this was a pizza that had a 16-inch diameter. And I asked you to find out if this pizza was cut into 8 slices. Find me two things. Find the area of the whole pizza. Two, find the area of one slice. And 3, find the angle measure of each slice. Sorry, my handwriting's really bad right now. I'm trying to write quickly. Of each slice. So, let's say in this slice, I want you to give me that angle measure there, but give it to me in degrees and in radians. Do those 3 things right now. Pause the video and work through them. Alrighty, so let's start with finding the area of the pizza. Formula for area is pi r squared. So the area of the pizza is going to be pi times my radius, which in this case is 4, squared. So my area of this pizza is going to be 16 pi square inches. If it asked you to give it exact, that's how you'd leave it. Or if they asked you round to the nearest tenth, let's say. 16 pi equals 50.3 square inches. Good, decent amount of pizza. Next thing I wanted you to do is find the area of one of these slices. Well, there are 8 slices, right? And assuming they're all in equal size, let's just take my area divided by 8. And I'm going to get 6.28, which we'll call 6.3 square inches. That's the area of one slice. Because if I take that and multiply it by 8, I should get my total amount. Now for 3, I asked you to find me the angle measure of one slice here, and I asked you to do it in radians and to do it in degrees. So you may have tripped up on this one a little bit, but hopefully it wasn't too bad. You know that a circle has 360 degrees total. Once again, there's 8 slices, all being equal. So let me take my 360 total degrees divided by 8. And I'm getting 45 degrees. Nice round even number. And hopefully from the last lesson, you also know that a full circle has 2 pi radians. So let me divide it by 8. Now again, remember, if you can keep in your head how big a radian is, if I took this radius here and I tried to wrap it around my circle, you're going to notice that that radius stretches a little bit past my slice. Also remember that a radian is about 57 degrees, which is more than this. So I should expect a number less than 1. I don't have a full radian's worth of measure. Take 2 pi and divide it by 8. And what I'm getting is 0.785 radians. I could have left that as 1/4 pi as another option too, or pi over 4. Usually when people talk radians, they won't even do the fraction. Well, they'll do a fraction, but they won't make it the fraction as a coefficient. Like they won't say 1/4 pi. It would just say pi over 4 radians. And leave my answer in like that. So that's what I had asked. Now, what in Sam Heck does this have to do with finding the area of a pie or area of a slice and things like that? I just realized, do you guys say pie when you talk about a full pizza? That reminds me of a conversation I had with a friend in college about it. I'll talk about that in class. How about that? So we've gone and we've just found out how many degrees are in that pizza. Now, if you look at the steps I did for 2 and 3, you'll notice something very, very similar. In both of these cases, I just said, let me take a number and divide it by 8. That leads to the really simple shortcut of trying to find out if someone asked you, find the area of the sector. Well, if I want the area of this sector, by the way, that's the term for a slice. A slice is called a sector of a circle. If you were told, find me the area of that slice, you would just go, well, what's the area of the whole thing? Let me divide it by how many pieces I have. Alternatively, you could say, well, what portion of the circle do I have? Let me multiply that by its whole area. So let's do a more general example. Here's my circle. And this time I'm going to say I have a sector with a central angle of 50 degrees. The radius here is 7 inches. And I asked you, find the area of that sector. Well, you know how to find the area of the full circle. For a full circle, it would be pi r squared. But you don't have the full circle, do you? You only have 50 degrees of it. So if I were to take the whole circle's area and just multiply it by the portion that I have, I'm going to get the area of that sector. 50 divided by 360 times my radius squared, which is 49, is giving me, let me turn that into a fraction, math to frac. I'm getting 245 over 36. If you got 6.80, that's fine, times pi. And let me just round that to the nearest tenth. Multiply that by pi, and I'm getting 21 point, I'll call it 4 inches squared. That's the area of that little sector. Let's see if that's correct. Well, the area of the full circle would be pi r squared. So then that would be pi times 7 squared, which is 49 pi. So let me take 49, divide it by pi. Oh, excuse me, multiply it by pi. And I'm getting 153.9. Let me multiply that number by the portion of the circle I have, 50 over 360. That's exactly what I did up here. Times 50 over 360. And shouldn't be any surprise that I get the same exact number as before, 21.38. Area of a circle is that simple. What's the area of the full circle? Multiply it by the portion you have. Here's where it gets a little bit more complicated. You might be given it in terms of radians. So you might be told, here's my circle, and I have an angle that is a measure of 2 radians. I had to think about that one for a sec. And the radius is 4 miles. Find the area of that sector. Well, again, area of the full circle would be pi r squared. But I don't have the full circle. Instead, I have 2 out of a possible 2 pi. Remember, there's 2 pi radians in the whole thing, and I only have 2 of them. So let me just multiply those 2 together. You'll notice the pi's here cancel out. In fact, everything cancels out in this one. It would be 2 pi over 2 pi, boop, times r squared. So in this case, it's exactly equal to 16 square miles. But we can do a problem that's a little bit more challenging with radians. Oh, sometimes they'll give it to you just in text. They'll say a sector, or a circular sector, or a sector of a circle. A sector has a central angle of pi over 5 radians and a radius of 6 centimeters. Find its area. Even though you get fractions and stuff, not too wild. Again, think to yourself, if I had the full circle, that would be its area, pi r squared. But I don't have the full circle. Instead, I have only a portion of it. I have pi over 5 out of 2 pi. So, multiply them together. Pi over 5, or 0.2 pi, over 2 pi times pi times 36 radius squared. So then we're going to type that whole thing into the calculator. Now, this is somewhere you want to be really careful with your parentheses. I'm going to plug it in. I'm going to plug it in as pi over 5, and I keep that. I really hope this shows up on the screen. Just a number in parentheses. Divide that by 2 pi, and you need to make sure that whole denominator 2 pi is in the parentheses. I'm moving it around, so hopefully at some point it's visible. Then I'm just going to multiply that by 36 pi. And I get an answer of about 11.3 square centimeters. So that's areas of sectors. Sometimes you might be given the angle of you'll be given the measure of the arc. So you might be given, here's my circle, and they can either give this to you in a picture or they can give it to you in text. So just be prepared for both. And they might tell you, let's say if this is A, B, C, they might say that the measure of arc AB is equal to 40 degrees. BC is equal to 10. And then it might say, give me the area of this shaded sector. Sectors don't really have a naming convention. Usually it'll just say the shaded portion. Or it might say, find the sector bounded by the arc AB, but there is no, like, sector AB. That's not a thing. So there really is no agreed upon convention of writing that. But sectors are very, very simple. All it is just ask yourself, what would be the area of the whole thing? Multiply it by the portion that you have. Same exact concept comes into play with the next idea, which is arc length. Now, before I go in showing it, I just need to explain what arc length is, because it's where people make some mistakes and get confused. Arc length is exactly what it sounds like, the length of an arc. But I just want to point out what I mean here. Here's a circle. Here's another circle. Center of this circle, center of this one. Boop, boop, boop. Let's say I asked you, or if I told you, those are both right angles. Give me the measure of both of these arcs. Well, hopefully you remember that a central angle has the same measure of the arc it subtends, meaning this arc is 90 degrees and this arc is 90 degrees. That is the degree measure of those arcs. And by the way, that's the same thing as saying you have pi over 2 radians in both cases. That's the measure of the arc, not in its length, but in its central angle measure. That tells you what portion of the circle is cut off. If you look between these two circles, all circles are similar shapes. So because of that, if I take a quarter of this circle and a quarter of that circle, what I'm left with is a similar shape in both cases. So we measure that as being a degree measure or a radian measure. But if I had a length of string or a length of measuring tape, and I laid it down across this arc here, and I cut it, and I tried moving it over to this one, I wouldn't cover the whole arc. So that's what the concept of arc length is. It's you have a circle and it's literally asking you, if I took a length of string and I wrapped it around the circle, how long is that string? Like if I were to actually lay that down on a ruler. Finding arc length is just as easy as finding areas of sectors. You just need to make sure you don't mix it up with its angle measure. So I'll give you an example first. Here's a circle. And let's say you're told, okay, this is circle K. And these points are A and J. And I tell you the measure of angle AKJ is equal to 28 degrees, and KJ, which is a radius, is equal to 5 meters. First thing I ask you for is give me the measure of arc AJ, and 2, give me the arc length of AJ. Two different numbers, two different concepts. See if you can do it on your own real quick and pause the video. So, first one should be easy. If this central angle is 28 degrees, arc AJ better be 28 degrees as well. So that's that portion done. Again, that just means how big of an arc in terms of the circle you have. 28 out of 360 degrees is not a lot. Now the arc length of it, well, for that I would say first, what is that term for the outer rim of a full circle? If you remember, that's the circumference. And the formula for circumference is just pi times the diameter. So in this case, since my radius is 5, my circumference would just be 10 pi. But I don't have the full circumference. I only have this portion of it, the portion that's determined by that central angle, or I only have 28 out of 360 degrees. So let me take 28 out of 360 and multiply that by the circumference formula. 28 out of 360 times 10 pi gives me 2.4-ish meters. Now, one quick thing just to point out here, you're going to hate me for this. Area of a circle, capital A. Circumference, capital C. Arc length, lowercase s. That's just the symbol we use. Arc length is given by an S. S is equal to the portion of the circle you have times what would be the whole diameter. So in this case, my arc length equals 2.4 meters. Done and done. Do another one. Here's a circle. And here is an angle. I'm gonna get a little crazy with you. I'm gonna get wild. This is a 110 degree angle here. And I'm gonna give the circle names like A, B, C, and circle O. And I asked you for, give me the arc length of arc ABC. I need to give you one more thing in here, don't I? You need to know what the radius is. Radius AO is equal to, I don't know, 8 millimeters. So give me the arc length of ABC. So again, arc length is equal to the portion of the circle that you have times what would be its full circumference, because circumference is equal to pi times diameter. So in this case, well, if I want ABC, I'm looking for this portion. I need to know this angle. Well, that would be 360 minus 110. So that means this angle here is 250 degrees. I did that right, didn't I? Come on, I've only got a master's degree. 250 degrees. So I've got 250 out of 360 degrees times pi times 16. Remember, it's times the diameter when you're doing arc length. So then, I'm just going to have you round this to the nearest tenth. Don't even have to give it in terms of pi. 250 over 360, you can even hit enter, times pi, enter, times 16, enter. So you get a total of 34.9 millimeters. Arc length is measured in a linear measurement because it's literally that length around it. It's, again, picture taking string, wrapping it around the circle, and then just measuring the length of string you would need. I just want to point out one more thing to hopefully differentiate in your mind arc length versus arc measure. I'm going to give you two circles now. Whoops, that's a line. Two circles now. That one there, and this one here. In this circle, I am going to have an angle. I'm using a lot of degrees in this problem, but remember, you could just as easily have them in terms of radians. So that formula I gave you before, where I said it's equal to theta over 360 times pi times diameter, that's assuming your theta is in degrees. If it's not, if it's in radians, same exact idea, except you have a certain number of radians out of the 2 pi total ones, times pi times diameter. There's actually a really simple formula for arc length if you have your measure in radians. If you're measuring in radians, I'll give that to you later. Gotta save some secrets. Let's do this one first. Okay, here I'm giving you an angle of measure 40 degrees with a radius that's equal to 12 feet. Here, I'm going to give you a circle with an angle measure of 20 degrees with a radius of measure, and this is not quite to scale, but I'm going to make it 24 feet. Find me the arc length, there to there, and there to there of both. In the one on the left, the arc length is going to be theta out of 360 times pi times diameter. So that's going to be 40 out of 360 times pi times 24. So then, again, I'm going to round to the nearest tenth. 40 out of 360, I'll keep that in parentheses. Another set of parentheses pi, another set of parentheses for my diameter. I'm getting 8.4 feet as that arc length. Same thing over here. Arc length is the portion of the circle I have times what would be the full circle's arc length, what we call its circumference. So then that would equal 20 out of 360 times pi times 48. Equal to, well, I've got 20 out of 360 times pi times 48. And I'm getting the same number. So the reason I'm pointing that out is these two circles, the arc formed here is not the same portion of the circle as this one. In other words, this arc, since that has a measure of 20 degrees, that has a measure of 40 degrees, I have less of the circle here. But since this circle is twice as big, half of the angle measure gives me the same length around it. So remember, there is a relationship between arc measure and arc length, but they're not the same thing. There is a difference between the two of them. So keep all that in mind as you go through. I'm debating if I want to give you the fancy schmancy arc length. No, I'm going to tell you got to tune into class, and I'll give you the fancy schmancy arc length formula when you're dealing with radians. Let's just do one quick example with radians, though. Here's a cycle, and we're gonna get fun and do a nice little review at the end here. I'm gonna give you this circle, and I'm gonna say, hey, this here is I've got an angle measure here of 1 radian with a radius of 4.5 miles, and I'm going to tell you, give me the area of the sector and give me that arc length. Do both. So for the area of the sector, again, area of a full circle would be pi r squared, but I don't have the full circle. Instead, I only have a certain portion of it determined by this angle. Well, it's the 1 radian out of the 2 pi possible radians. So my area is 1 over 2 pi times pi times 4.5 squared. What unit is this going to be in? Well, it's area, and since I was measuring the linear part in miles, I'm expecting, because I've got miles times miles, miles squared to be my unit. So you can do a little bit of algebra here and say, okay, that would be pi over 2 pi, which means the pi's cancel out, so that's just 1/2 of 4.5 squared, or you can plug that whole thing into your calculator. 4.5 squared, now let me take half of that. I'm getting an area of the sector that's about equal to 10.125 square miles. Again, that's not the area of the full circle, it's just the area of that sector. You're always able to find the area of the full thing and then just take the portion that you have, which is exactly what we do here, the area of the full thing times the portion. Now let's do arc length. Again, arc length is, well, the full circle would be pi times the diameter, but I don't have the full thing. Instead, I have 1 radian out of a possible 2 pi radians. So my arc length is equal to 1 over 2 pi, which again I can just keep as 1/2 because those pi's cancel out, times 9. So my arc length here is 4.5 miles. That shouldn't be a surprise at all. Since my angle measure is 1 radian, remember, a radian is determined by the angle that cuts off in arc length exactly equal to the radius. So since this measure is 1 radian, I should expect it to be 4.5 miles. Just like that, we done. Thank you guys for tuning in. Let me know if you got any questions.